So, good afternoon, everyone. I'm Hyojin Lee from SPH as a Global Marketing Manager. Today, we will be discussing remote sensing and SAR satellite imagery analysis and satellite imagery utilization system using deep learning model. This system is a project that we have been researching and developing together with the Satellite Geophysics Laboratory belonging to Seoul National University. It's been starting for 3 years already. In addition to that, we have plans to develop some functions and deep learning models more in 2023. So before we go any further, I would like to introduce SPH briefly. SPH started GIS activities as a Google Maps enterprise partner in 2011, and we are currently the only Google Maps premier partner in Korea. In 2013, we started a partnership with SuperMap as an exclusive distributor, also received the Best Channel Partner of the Year in 2021. Besides, we also work with GIS companies including Carto and Maxar, as well as with Monday.com, which is a project management software. Also, Tableau data visualization software. With these partnerships, we have lots of opportunities. Now let's return to SuperMap. SPH has been using SuperMap products to provide solutions and business systems to schools, government agencies such as Korean Forest Service or Korean National Police Agency, also private enterprises including Asian Airlines and city gas companies. Prior to this, the remote sensing and SAR satellite imagery analysis and synthetic aperture radar, namely SAR, is an active electromagnetic wave radar sensor that obtains imagery information using microwaves. It is possible to show high-resolution imagery over a wide area, regardless of day or night, as well as limitations due to weather conditions such as clouds, fog, and snow. For your information, active sensors transmit signals direct from satellites and measure the signals reflected back from objects. So it means that it can be observed at any time or any weather conditions. But unfortunately, however, it doesn't utilize the wavelength range such as visual light. Its characteristics and compositions are different from RGB imagery. It is difficult to perform general. To digress a little bit, I would like to explain the background and purpose of creating this system. There are two main reasons why it was necessary. In the past, prior to this system, it was not efficient in sharing and utilizing satellite imageries because institutions needed to monitor and manage them one by one every time. Therefore, they decide to make it an integrate, see, use, and download it. The second reason is that they want to analyze satellite imagery with deep learning technology, but since each satellite imagery comes from different models, and even there is no standard models that analyze them are not same though. So through the utilization system we made, spatial data in each satellite imagery was extracted and made to be able to see the whole data. Additionally, we are trying to develop this system for such as data processing for now. For these reasons, we have created a system for utilizing and sharing satellite imagery processed by institutions and individuals. Furthermore, this system uploads satellite imagery automatically, also shows and stores massive data. It can be helpful to make multiple observations and diverse analysis for a comprehensive understanding of Earth systems and environments. So let me now come back to today's title. It can be divided into two services. First of all, remote sensing and SAR satellites imagery AI web service. Second is satellite imagery utilization system. There is a generation process of the deep learning model. First of all, we collect satellite imagery data and build training data of the imagery. And we select the model, including loss function and variables for object detection or imagery analysis based on this. After this, we rerun the model with the running data and adjust parameter values, then create a deep learning model. Then we move on to the final step. We input images to the trained deep learning data model to detect various spatial objects and generate analyzed result data. It's important to select the optimal variable for the performance and learning of the deep learning model. But since it's more important to select high quality training data, so it's true that it takes a lot of time and money to build training data in the beginning. Through the data learning, we have 10 types of deep learning models of spatial object detection categories, such as boats, water systems, bridges, and wind turbine. Also, 3 types of analysis deep learning models can analyze floods and oil spills on imagery. As you can see, there are some examples of spatial object model. Through the deep learning model, we can use spatial objects and analyze models detected in various fields. So first, for ship detection, it can be used in areas of maritime security, such as control of illegal fishing, as well as monitoring maritime pollution like oil spills. Vehicle detection is counting the number of vehicles for the people's area of interest. So it could be used for marketing and research materials if needed. When it comes to building detection, it can be monitored in a variety of sections. For instance, keeping an eye on the progress on large-scale construction works and illegal land or illegal construction buildings use. Oh, and when it comes to the natural disaster analysis, so when it happens like a forest fire and landslide or earthquake, we can figure out the size of the affected area and damaged buildings on the natural disaster analysis. Moving on to the next slide. So to put it more simply, the analysis satellites imagery utilization service is a data visualization and sharing system of imagery data. So authorized institutions and individuals can access this utilization service to find the analyzed imagery or download massive data. The analysis Imagery Utilization Service implements with SuperMap AI server and SuperMap AI client for Mapbox GL and provides a function to search and visualize provide from government and weather data as well as AIS data collected from ships. In remote sensing and SAR satellite imagery AI analysis service, spatial object detected data and visualization are performed through the following process as the table below. So step 1, the analyzed imagery utilization service uses the data collection API to collect spatial object detection data and imagery analysis data from AI analysis service. And step 2, the collected data uses the data pre-processing module to perform data processing for issuing AI server services, such as coordinate transformation, data conversion, UDBX generation, and data import. Step 3, the SuperMap AI server service issue module let pre-processed data issued to AI server REST map service and AI server REST data service. Lastly, the newly issued AI server REST service is visualized using the analysis imagery utilization system. So let me introduce some visualizations models. First of all, satellite imagery data visualization is a function that presents remote sensing and SAR satellite imagery with location information and distortion collection imagery on the map. We can search satellite imagery data used for training data of AI analysis service, and as well as new updates of data collected periodically. So we can check various satellite imagery such as Sentinel satellite, Landsat satellite, and Japan's geostationary orbit meteorologically satellite Himawari. The next one is satellite imagery analysis data visualization, which is literally the function that uses the remote sensing and SAR satellite imagery AI analysis service. So we can find spatial object detection and figure out data results and visualize the imagery data on the map. So as I mentioned earlier, we presently possess total 13 types of spatial object detection models, including ships, water systems, floods, and so on. Move on to the next slide. It's a service that utilizes open APIs for 182 types of public data managed by the government, for instance, public safety and transportation. The GIS data visualization is a function that shows on a map by combining a spatial data open API and the SuperMap AI server REST API in the form of other spatial data. Among 182 types of data, we have 60 types of open data essential for display imagery analysis data. When it comes to automatic identification system, in short, AIS is automatical tracking system that exchanges between ships and land-based stations. With this device, the AIS data visualization displays ship information such as weights, lengths, positions, and speed or bearing of the ship. It's collected every 5 minutes using the AIS device and show the ship's past movement routes also. It can be mainly used to prevent ship collisions or search and rescue in the marine accidents. Additionally, we have some choices of background maps provided in this system. We provide three-word area imagery that shows the South Korean area in high resolution, OpenStreetMap that covers the whole world area, and lastly, global satellite imagery maps. For reference, three words is a national spatial information open platform that is provided by the Korean government so that all citizens can freely watch and use it. The analyzed imagery utilization service is divided into general users and administrations. And there are some functions that can be used only by admins. So to be specific, the user management is a function to add, modify, and delete users who can use the utilization system. The second one is the imagery data deletion is a function to delete the data of imagery utilization service or the map and data service published by iServer. In terms of spatial object detection type management, this function is added spatial object detection type when new deep learning models is added. Also, the updates of spatial object detection type is also automatically uploaded in the imagery analysis data section. Lastly, we will end the presentation by introducing video demos of the satellite imagery analysis utilization service. So first, as you can see, we can find water detection. So we can choose the data we want. So figure out what the river is like. And for the fire, same with water detection. So we can expect what the situation would be like if there was a forest fire. And also, you can see the dates or by day, you can select date or satellite models and you can search the specific keyword. And you can check the city or region. And also zoom in and zoom out is quite fast. And for the AIS data, it's updates every 3 to 5 minutes. So we can keep up the date with the new updates. So we can know routes or ships information. And we can check weather conditions. And lastly, there are some kinds of background maps for you can set up as you need. So to keep up watching changes and situations in the global environment, many types of satellite data is needed. So we expect that our remote sensing and SAR satellite imagery system will be helpful in integrations of these various types of satellite imagery data. So, sorry. Yeah. So thank you for today. Thank you for listening today and thank you for your time. Thank you.